Okay, here we're going to find relative extrema and inflection points if there are any. So we'll start right in with the derivative. Y prime is 1 minus 1 over x. Set it to 0. Let's see, that would be negative 1 equals negative 1 over x. So x equals 1. Okay, so x equals 1 is critical. Okay, here notice that x equals 0, which is possible place for an undefined derivative, is not in the domain anyway. So we'll ignore that. So we have a critical number. And now we have choice here. We can use our first or second derivative test. I'm going to use the first derivative test just to practice it a little bit. So we'll have 1. We've got to be careful about this when we test it because I'm going to stay in the domain. The domain is x greater than 0. So we have to pick like a half here, and we can pick a 2 over here. So we need to calculate those. Y prime of 1/2 is equal to 1 minus 1 over 1/2. And it's 1 minus 2, which is less than 0. So that's negative. What about y prime of 2? Let's put that in, like 1 minus 1 over 2, which is greater than 0. That's a half. So you know what this means. It means you're decreasing, going in this way. You've got a relative minimum there. Okay, relative min. What are the coordinates? Well, y of 1 equals 1 minus natural log of 1, and that's a 0, so this is just 1. So there's our relative minimum located at 1, 1. All right, let's look at some inflection points then, if there are any. We have to work with our second derivative. Y double prime would be a 1 over x squared. And that's because y equals 1 minus x and negative 1. So differentiating, we will get this. Okay, is that ever 0? No, it's never 0. And x equals 0 gives an undefined location. Now, this quantity, notice, will always be positive. So that means this graph is concave up everywhere where it's defined on its domain. And there were no inflection points.